Yeah, everybody listen here. What is this problem all about? See, we are asked to find out I1 of 0 plus, that is I1 is here, IL is here. I1 of 0 plus and IL of 0 plus we have to find out in this particular circuit. Okay. And one information that we need to extract from the circuit is the symbol of the switch. What is the symbol telling you? This symbol very clearly tells that at t equal to 0, the switch is closed. Okay, at t equal to 0, the switch is closed. That means at t equal to 0 minus, the switch was open. At t equal to 0 minus, the switch was open. At t equal to 0, the switch is closed. Okay, that means at t equal to 0 plus, the switch is just closed. Everyone understand? Okay, so that is what we the information that we need to gather from this. Okay, and one more thing that they're telling us is the circuit is at steady state for t less than 0. That means at t less than 0 means before it is closed. Before the switch is closed, the circuit was in steady state. I didn't use this word steady state yesterday when I was explaining the things. What is steady state? Steady state is something wherein there will not be any changes in the conditions. That means what? If the switch is open for a long time, the circuit is in steady state. If this switch closed for a long time, then it is in steady state. But at t equal to 0 plus, the circuit is not in steady state, because after closure of the switch, it is just moments after that. Just moments after that. That's why it is not steady state at t equal to 0 plus. That means when would the steady state reach? When would the circuit be in steady state? The circuit would be in steady state, okay, before the closure of the switch. Why? Because it was before the closure of the switch, it was open. It was not just open, but it was open for a long time before it is closed at t equal to 0. Is that understood, everybody? So the circuit was in steady state means the switch was open for a long time before it is closed at t equal to 0 is the meaning. Is it understood? So let's summarize that. Since this is the first problem, let's understand what all is given there. Solution. Okay. From the symbol, everybody just take down this. From the symbol of the switch, what is clear? From the symbol of the switch, we understand this switch is being closed at t equal to 0. Okay, the switch is being closed at t equal to 0, which means that it was open for t less than 0. Okay, fine. That is, switch was open for t less than 0 for a long time. Switch was open for t less than 0 for a long time is what one needs to understand here. Is this okay with you? Now, let's do this now. What is it asked? What is asked? We are asked to find out I1 of 0 plus and IL of 0 plus. Okay. What is IL of 0 plus? We need to understand. Okay. So if you have to understand IL of 0 plus, we need to understand what is IL of 0 minus. Okay. So can we write this circuit at t equal to 0 minus? Because if you write the circuit and understand what is IL and I1 at t equal to 0 minus, okay, it is as good as obtaining IL of 0 plus. If you obtain IL of 0 minus, IL of 0 minus is actually equal to IL of 0 plus. How? Yesterday we have seen. The current through the inductor will not change instantaneously. Whatever was the current at t equal to 0 minus is the same at t equal to 0 plus, because to change it needs a lot of time. But 0 plus, from 0 minus to 0 plus is very less time, and in that less time the changes will not happen. So whatever was existing at t equal to 0 minus, the same current would exist at t equal to 0 plus through the inductor. So what is that we have understood yesterday? This indicates that the current through the inductor does not change instantaneously. That means for change it needs time. So it will not change instantaneously is what we have understood. So they've asked us IL of 0 plus. So to understand what is IL? IL is the current that is flowing through the inductor. There is a resistor, not a problem, but you should understand IL is also a current that is flowing through the inductor. Okay, so IL of 0 minus would be IL of 0 plus for the inductor. Okay, so first let's write the circuit diagram for IL of 0 minus. Okay, now everybody see this. At t equal to 0 minus, the circuit is in steady state. The circuit is in steady state. Okay, what does that mean? Switch was open for a long time is the meaning of this. The circuit is in steady state means the switch was open for a long time. That is why the circuit is in steady state. When is it in the steady state? At t equal to 0 minus. T equal to 0 minus means t less than 0. Everybody understand? T less than 0 is what the steady state has been reached. That means at t equal to 0 minus also there is steady state. Understand that? And one more thing that you should understand is in steady state, this inductor works as what? How can we realize this inductor in steady state? Okay, everybody just lend your ears and concentrate. See here, these are the conditions that we have obtained yesterday. Suppose I of 0 minus is 0. That means I of 0 plus is also going to be 0. Initial condition. Fine. So this is final condition. So this is in final condition only you will have what? The steady state. Okay, this is steady state. Understand? At t equal to infinity we are saying, right? That means after a long time, okay, the circuit reaches the steady state. So when circuit reaches the steady state, the inductor works as what? The inductor works as short circuit. Okay, so let me just give you, this is steady state. Okay, at t equal to infinity means you should understand this is steady state condition. In steady state, L is realized by a short circuit. Understand? L is realized by short circuit. What is happening here? Whatever is I of 0 minus, I of 0 plus would also be same. Understand that? But you understand this. Steady state means final condition. In final condition, the voltage across the inductor is 0. Means when would voltage be 0? Voltage be 0 when there is no resistance. So that means we have to short circuit that. So at steady state, what is happening? Inductor is what? Short circuit. Okay, so that information we need to gather here. In steady state, everybody write this. In steady state, in steady state, L is replaced by a short circuit. Replaced by short circuit, that's not replaced by short circuit. Okay, so therefore at 0 minus, at t equal to 0 minus, therefore at t equal to 0 minus, the circuit becomes this. At t equal to 0 minus, which is not closed, mind you. Okay, so this we need to write. At t equal to 0 minus, I'll write this circuit. Everybody just see here what's happening. This current will anyways be there at t equal to 0 minus. Okay, but what would happen to this switch? This switch would be open. The switch is open at t equal to 0 minus. Okay, now there is a resistor which is 1 ohm, and what is flowing here? I1 of 0 minus is flowing, mind you. Okay, then you have the inductor has to be replaced by a short circuit. Okay, then you have another resistor which also is 1 ohm. Everybody okay with this? So what is the current that is flowing here? It is IL of 0 minus. So the current flowing here is 2 amps. So this is how the circuit looks like at t equal to 0 minus. Okay, so let's copy this. Yeah, this is how it is going to look like, the circuit going to look like. Now what happens to this 2 amperes? What happens to this 2 amperes comes at this point? Do you think that 2 amperes flows here? Do you think that 2 amperes flows here? No, it will not flow, because here it is, switch is open, so it is open circuit. So this 2 amperes will come here. Okay, so there are two resistors in parallel and both are same resistance. That means this 2 ampere after coming here will get divided into two parts. One part will go here, the other part will go here. Since both the resistors are same, this 2 ampere will get divided into two equal parts. That means it is 2 amperes. Two equal parts means 1 ampere will flow through this, another 1 ampere will flow through this. Understand that, everybody? Okay, so we can say that therefore I1 of 0 minus is 0 amps. Sorry, very sorry. What is that? Yeah, it is 1 amp. Similarly, IL of 0 minus is also 1 amp. Everybody understand? This is not what they have asked. They have asked us to find out I1 of 0 plus and IL of 0 plus. But we have understood what is going to be current at IL of at t equal to 0 minus. This is at t equal to 0 minus. Okay. But one thing that we have seen tells us very clearly that current through, since current through the inductor does not change instantaneously. IL of 0 plus is actually equal to IL of 0 minus, and that is equal to 1 amp. Okay, so IL of 0 plus they had asked, so we obtained IL of 0 minus, and we know IL of 0 minus is IL of 0 plus, so IL of 0 plus is 1 amp. Is this understood, everybody? Okay, but I1 of 0 minus would not be equal to I1 of 0 plus, since this is the current through the inductor. See here, since IL is the current through the inductor, IL of 0 minus is equal to IL of 0 plus. But current through the resistor, this is not only current through resistor, this is current through the inductor. You should not mistake. But this I1 is purely a current that is passing through the resistor. And what is the current through the resistor here? See here, IL of 0 minus is not equal to I of 0 plus. I of 0 minus, that means the current through the resistor, I'm saying. The current through the resistor changes instantaneously. Voltage also changes instantaneously. That's why I of 0 minus is not equal to I of 0 plus. So that means since this is I1 of 0 minus, we cannot say I1 of 0 minus is equal to I1 of 0 plus. No, because this is a current through the resistor. So what we need to do to find out I1 of 0 plus, we need to understand. Okay. Now let's see. To find, what we're doing here is, why we are doing this is to find I1 of 0 plus. Why we are doing this? Because I1 of 0 plus is not equal to I1 of 0 minus. Okay. So this is just in R, in resistor. Okay. I1 of 0 plus is not equal to I1 of 0 minus. So this is the reason we are going for finding out I1 of 0. At I1 of 0 plus, how does it look like? And mind you, I1 of 0 plus is not what? It is not the steady state condition. At I1 of 0 plus, circuit is not in steady state condition. When it is not in steady state condition, you write this as it is. Understand? Or if there is a current IL flowing, before the same current would be flowing through this, is what we've understood. Okay, so at 0 plus, what happens? At 0 plus, what is going to happen? At t equal to 0 plus, the switch is closed. Obviously the switch is closed. Okay, so this is one. The switch closed. This is resistor 1 ohm. Okay, so let's write this as inductor only. Let's not bother much about that. It is not anyways going to do anything. Because we already have found out IL of 0 plus. Okay, so what is here? This is I1 of 0 plus. Okay, this is 2 amp. So this is how it is going to look like. Now, can anybody tell me what is I1 of 0 plus from here? Is anybody ready to give me what is I1 of 0 plus? Okay. Now, can you tell me what is I1 of 0 plus here? I1 of 0 plus. Anybody? What would happen to this current after it comes at this point? Earlier, this current after coming at this point, it has no path here. It is open circuit. So this current has to move to this particular point in the previous case at t equal to 0 minus. But at t equal to 0 plus, the switch is closed. This is switch closed. So this is switch closed. Understand that? So this 2 amperes, after coming at this point, what is happening to 2 amperes? It will find this short circuit here. Okay, but here it has got some resistance. Here also it has got reactance and resistance. So what will this 2 amperes do? This 2 amperes will keep flowing in this path, because here is a resistance, here is a resistance. There is no resistance here. That means when there is a short circuit, so this branch is in parallel with short circuit, this branch is in parallel with short circuit. That means all these are redundant now. This will not come into picture. Whatever is the resistance there, this part will not come into picture at all. Whole of this 2 amperes will flow through the zero resistance path, the short circuit path. So the 2 amperes keep flowing like this. Understand that? Because this is the This is the path with zero resistance. So when current has a path with zero resistance, whole of the current flows through that. Okay. So therefore we can say, therefore we can say I1 of 0 plus is what? 0 amps. Why? This current will not go here at all. Whole of this current will keep flowing in this particular path. Understand that? So we have found out what? I1 of 0 plus. Fine. So we have found out IL of 0 plus also. But to find out IL of 0 plus, finding out IL of 0 minus was sufficient. Understand? Okay. But I1 of 0 minus is the current through resistor, and current through resistor will change instantaneously. That means I1 of 0 minus would not be equal to I1 of 0 plus. That's why we had to find out I1 of 0 plus by writing the circuit diagram at t equal to 0 plus. Is everybody okay with that? Yes? Now, let's go with another problem now. Yeah. Now, in the earlier circuit, what was happening to the switch? The switch was being closed at t equal to 0. Okay. Switch was being closed at t equal to 0. That means it is before the closure, the circuit was in steady state. That means the switch was open for a long time. And after being open for a long time, at t equal to 0, it was closed. Now, what's happening here? Assume that the switch was closed for a long time. That means here the arrow is showing that the switch is being opened at t equal to 0. The switch is being opened at t equal to 0. And what is it saying? Since it is being opened at t equal to 0, it was closed for t less than 0, and it was closed for t less than 0 means it was closed for a long time. Since it was closed for a long time, at t less than 0, when the switch was closed, the circuit was in steady state. They have not used the word steady state here. They have not used the word steady state. Okay, but we need to understand, when the switch was closed for a long time, with switch closed, the circuit was in steady state at t less than 0 is what we need to understand. Okay, there are two different symbols. Fine. So let's summarize the understandings first. This is solution. So whatever we have understood is this. Okay, the switch is being opened at t equal to 0. The switch was closed for a long time, they are saying. For a long time. Long time. At t less than 0. Okay. So therefore, at t equal to 0 minus, at t equal to 0 minus, do you think the circuit was in steady state is the question. The switch was closed for a long time at t less than 0. So this is also t less than 0 only. 0 minus is also t less than 0. At t less than 0, switch was closed for a long time. Okay. Since the switch was closed for a long time, the circuit was in steady state. Therefore, at t equal to 0 minus, what we can say is the circuit was in steady state with switch closed. Okay. So therefore, at t equal to, sorry, another thing that we need to understand is, when in steady state, what is C acting like? In steady state, C acts as what? To understand that, yesterday we have done this, right? See, in steady state, inductor acts as short circuit. In steady state, the capacitor acts as open circuit. Infinity, at t equal to infinity we are showing, right? So at t equal to infinity, what's happening? The capacitor is replaced by what? Open circuit. Okay, so that we need to write. Fine. Therefore at t equal to 0 minus, the capacitor is replaced by open circuit. Understand this, it is replaced by open circuit. So therefore circuit becomes what? Therefore at t equal to 0 minus, the circuit becomes what? So let's write that here, then I'll copy paste. At t equal to 0 minus, I'm writing. Okay, at t equal to 0 minus, the switch was closed, mind you. Okay, at t equal to 0 minus, I'm writing plus minus 5 volts, and this switch was closed. Okay, and when the switch was closed, the capacitor is replaced by the open circuit, because with switch closed, the circuit was in steady state, isn't it? So the current will not flow, but the voltage drop would be there. And what is that voltage drop? It is Vc of 0 minus. This is 1 ohm. This is 1 ohm. So this is how the circuit will look like at t equal to 0 minus. Everybody understand that? Okay. Yeah, see, this is how it is going to look like. Now, can you find out Vc of 0 minus? What is Vc of 0 minus? It is the voltage, and this is the voltage that is dropping across this 1 ohm. Okay, if this is Vc of 0 minus, okay, the voltage that is dropping across 1 ohm is also Vc of 0 minus, because these two branches are in parallel. Understand that? So you can say this also is Vc of 0 minus. So that means this also is Vc of 0 minus. Okay, so when there is 5 volts, there will be a current flowing. Okay, let's say that is I. KVL says what? KVL says minus 5 plus 1I plus 1I equal to 0. It implies that 2I is equal to 5. Further, it implies that I is 2.5 amps. So we have found out I. So if you find out I, what is Vc of 0 minus? What is Vc of 0 minus? Therefore, Vc of 0 minus is equal to what? It's 1 into I. So it is 1 into 2.5 amps. So Vc of 0 minus is 2.5 volts. What is that we have understood for a capacitor? For a capacitor, what is true? For a capacitor, see, the voltage across the capacitor will not change instantaneously, is what we have seen yesterday. See here, voltage across the capacitor will not change instantaneously. That's why if you know V of 0 minus across the capacitor, that V of 0 plus is also equal to V of 0 minus. Okay, so you should say that here. Since everybody say that, since VC, voltage across the capacitor, does not change instantaneously, okay, Vc of 0 plus is actually equal to Vc of 0 minus, and this is equal to 2.5 volts. This is how we find out the voltage VC of 0 plus.